Their bones prove they were thriving 40 genera, every ocean, peak health days before the end. Then zero, not one fossil above a thin line of clay. It was a cascading starvation. A single glance at the fossil record reveals a reign without rival. Mosasaurs, in more than 40 distinct genera, conquered every ocean basin on Earth. Their lineage stretched across 32 million years, from the shallow chalk seas of ancient Europe to the vast open corridors of the western interior seaway. At their peak, these reptiles produced giants. Mosasaurus hoffmanii, nearly 17 meters long and weighing 15 tons, could swallow a dolphin whole. Tylosaurus, with its elongated snout and torpedo-shaped body, matched the length of a city bus and outpaced most prey in open water. Even the specialized Hinosaurus and Plotosaurus evolved profiles so streamlined that modern biologists compare them to great white sharks, a design achieved independently, millions of years before sharks themselves would rise to dominance. Mosasaur fossils have been unearthed on every continent, from Morocco to New Zealand, from the Arctic shelf to the southern tip of South America. Their bones cluster in the richest marine sediments of the Cretaceous, evidence of a population that filled every ecological niche above the seafloor. These were not scattered survivors at the edge of extinction, but the undisputed apex predators of a global ocean, thriving at the very threshold of disaster. Bone chemistry leaves no room for doubt. In the final days of the Cretaceous, mosasaurs were not fading relics. They were thriving, drawing their strength from a single, stable calcium reservoir that spanned the world's oceans. Calcium isotope ratios, measured in the enamel and bones of mosasaurs from North America, Europe, and Morocco, cluster tightly around plus 0.3 per mil. This signal is not random noise. It is the chemical signature of apex predators feeding at the top of a productive food web, with every sampled individual showing the same robust enrichment. The calcium in their skeletons matches the composition expected from a diet rich in bone and shell, drawn from abundant ammonites, fish, and marine reptiles. Laboratory screening rules out contamination. Rare earth element profiles, strontium to calcium ratios, and cathodoluminescence imaging confirm that these are primary biological signals, not the ghosts of post-mortem alteration. The uniformity of the isotope data, from the western interior seaway to the Tethyan margins, locks in a picture of global ecological vigor. In the final geological moments before the asteroid, mosasaurs were still at their evolutionary peak, no sign of starvation, no chemical trace of decline. The proof is written in their bones. 66 million years ago, a 10-kilometer asteroid struck the Yucatan Peninsula with a force that dwarfed every volcanic eruption or earthquake in Earth's history. The blast gouged a crater 180 kilometers wide and hurled trillions of tons of rock and sulfur high above the atmosphere. Within minutes, incandescent debris rained back to the surface, setting forests ablaze from the Arctic to Patagonia. But the ocean's crisis began with darkness. More than 90% of sunlight vanished as a global shroud of dust and sulfate aerosols spread across the planet. Photosynthesis in the upper oceans ceased almost overnight. The surface waters, once teeming with plankton, fell into a suspended twilight. At the Tanis site in North Dakota, fish fossils preserve glass spherules embedded in their gills, fragments of impact ejecta inhaled while still alive, a silent witness to the first moments of catastrophe. Yet even in this chaos, the initial blow did not kill everything outright. Some marine life, including mosasaurs, survived the first hours and days. The real threat was not the impact itself, but the sudden erasure of light and the silent collapse of the food web that followed. This was the first step in a chain reaction that would soon reach every level of the Cretaceous seas. Sulfur aerosols blasted into the stratosphere by the Chicxulub impact began a second assault on the oceans. As these particles rained back to Earth, they reacted with seawater to form sulfuric acid, driving a chemical shockwave through the surface layers. Within weeks, the pH of the upper ocean dropped by at least 0.3 units, a rate more than 10 times faster than any acidification event in the past 300 million years. This was not a gradual shift, but a sudden, corrosive plunge that swept across every ocean basin. Shell-forming organisms, already weakened by the loss of sunlight, faced an impossible chemistry. Ammonites, bivalves, and coccolithophores, creatures that built their bodies from calcium carbonate, found their shells dissolving around them. Laboratory experiments with modern analogs show that a drop of this magnitude strips away more than 70% of protective shells in days. The fossil record confirms the outcome: a near instantaneous disappearance of carbonate skeletons at the KPG boundary. For Mosasaurs, this was the second blow. Their entire food web depended on shell-forming prey, and as acid stripped the ocean of its calcium armor, the foundation beneath these apex predators collapsed. Ammonite larvae, less than half a millimeter across, once drifted in clouds through the sunlit shallows, an endless resource for mosasaur hatchlings and adults alike. But the collapse of planktonic life after the impact cut off this supply at its root. Without plankton, ammonite populations crashed in a single generation. Fossil beds across the globe record this silence. Below the KPG boundary, ammonite shells and mosasaur bones are abundant. Above it, neither is found. Stratigraphic surveys from the western interior, seaway to the European chalk, show an unbroken wall, no mosasaur remains, not a single tooth or vertebra in any post-boundary layer. The extinction is absolute. Mosasaurs, whose metabolism demanded constant intake of high-energy prey, had no physiological buffer. Unlike crocodilians, which could slow their metabolism and scavenge, mosasaurs starved as the food web unraveled. The boundary clay, just a few centimeters thick, is the verdict. A world where the apex predator's reign ended not with a single blow, but with the quiet, total erasure of every link in the chain that sustained them. In the end, evolutionary supremacy offered no refuge. When ocean systems failed, even apex predators at their zenith were erased. Today, ecological collapse still demands the same brutal arithmetic. No ruler is immune.